All right. Nice. So thanks, Richard, for an inspiring talk on how we should all be thinking about matters of reality. I want to motivate this community around how you all can use egocentric vision to do research on matters of reality with Project Aria and the algorithms we've made available to everyone now for reconstruction research. So my name's James Ford. I'm a research product manager with Meta Reality Labs Research. And I'm actually joined here with Chung Pan today, research engineer organization, and we're going to be doing some demonstrations live as well with Aria Gen 2 to give everybody a view of what the device is and hopefully motivate you all to use it in your research. Over 2 million Ray-Ban Meta glasses have been sold in the world since its debut at the end of 2023. And with its RGB camera, audio interactivity, and seamless connection to Meta AI, we are now watching the world adopt what Meta and the egocentric researchers in this whole conference have envisioned for years. At Meta, we believe that the evolution of egocentric wearable devices and the ever-growing capabilities of vision language models will transform the way we think of personal computing. It will become more invisible, influencing for us across language boundaries and anticipating the information that we need in the moment. And we're also at an inflection point in the robotics space. How many of you here in this room today have a focus on or interest in robotics? Can I just get a show of hands? I see, literally over half the hands in the room. Robotics hardware platforms are now at a state of affordability such that the computer vision community can develop experimental platforms and test out key hypotheses. Large language models evolved into vision language models, which are now evolving into vision language action models that can perceive the world and act directly from trained models. And the proliferation of large corporations and startups have begun developing humanoid robots with impressive demonstrations. Computing is becoming embodied in the form of humanoid robots. Wearable devices and humanoid robots both perceive the world from their own perspectives. That's what we mean by the egocentric perspective. And as you can see in this example of the hot 3D data set that we make available on projectaria.com, egocentric data captures the wearer's point of view and includes important information about the wearer's gaze, their position in 3D space, and how they interact with their environment using their hands. To put it simply, effective contextual AI systems for wearables and machine learning models for robot operation need egocentric data, and they need a whole lot of it. And as a community, we're asking critical questions about how much data is needed for breakthroughs in performance, how specific the data needs to be for certain tasks, how easily models can perform well on different sensor configurations, and even in different robot embodiments. Now, this leads to the mission of Project Aria. We started Project Aria in 2020 to accelerate machine perception and contextual AI research for wearables and robotics. And since then, both we and Meta and the brilliant minds in the egocentric research community have used OWL to generate new kinds of egocentric data sets to train and benchmark state-of-the-art models and creative prototype experiences and demonstrations that illustrate what's possible with wearables and in robotics. You've already seen examples today of this, and many more research applications are in the works. The first generation of Project Aria that Richard already demonstrated, we're now calling Aria Gen 1. It was launched in 2020, and our external program has grown tremendously since that launch. If you apply to be a partner to do research with Aria today, which I'll show you some links for shortly, we currently give out Aria Gen 1 glasses. Aria Gen 1 glasses are packed with sensors that capture the egocentric perspective. They contain a high-resolution 8-megapixel RGB camera, 2 high-field of view computer vision cameras for SLAM and hand tracking, 2 low-power eye tracking cameras, dual IMUs for trajectory and SLAM, and 7 spatialized microphones. The device contains a 2.5 watt-hour battery that can record up to several hours with certain sensor configurations, and there's a 128 gigabyte flash drive. It's truly a miniaturized computer in a pair of glasses. Over 240 research partners in 27 countries use now nearly 1,000 Aria Gen 1 glasses. Actually, it's over 1,000 Aria Gen 1 glasses as of today. These are the top computer vision, contextual AI, human computer interaction, and robotics labs and companies worldwide. And we now count 340 citations of Project Aria and Aria datasets and papers, spanning a breadth of publications that focus on the evaluation of vision language models with egocentric data. We'll be talking about this in EgoViz later today, by the way, to new innovations in robot training methods to foundation model development. And just earlier this year, we announced Aria Gen 2, our latest hardware with many improvements. We're working hard to make Aria Gen 2 available to the community in H1 of 2026. So here's an overview of the sensors and the connectivity on Aria Gen 2, and I'm going to point out a few key features. You can charge and connect Gen 2 via a standard USB-C port, and that's a major convenience upgrade from the existing custom cable on Gen 1. The 8-megapixel RGB camera on Gen 1 has been upgraded to a 12-megapixel camera with better dynamic range. I'll show that shortly. There are now 4 CV cameras for a greater field of view and 80 degrees of stereo overlap, and that enables depth applications that I'll show. And there's a contact microphone and stereo speaker to make it possible to hear voice and audio interaction, have voice and audio interactions with the device. So this is a pretty great view that shows the high dynamic range of our CV camera, and it makes it really easy to work with Aria Gen 2 in dynamic lighting conditions. You can notice in particular that when this lamp goes on, you can still see the full detail of the filament of the lamp. You can also make out the full detail of the outside space with the CV camera in areas where the RGB camera would be washed out. So this really makes it possible to do SLAM in diverse lighting conditions. And the addition of more CV cameras in Gen 2 with strategic positioning downward and out to the side, much like you might see in a full-fledged headset, produces significantly more stereo overlap. I'm going to show what that enables in terms of depth. And it captures hand movement both all the way out in the periphery and downward for greater hand tracking. We'll show that in the demonstration. So let's see if my audio is working here. I think I need to look. All right. So this is just a demonstration of the contact microphone working in a wind simulation, and I'll just let you listen. When you're using the glasses, the contact microphone will pick up vibrations from your own body and then be able to focus in on just the audio from yourself and sort of phase out the outlying, the surrounding distracting noise. So perhaps the biggest change for Aria Gen 2 is that Meta developed its own specialized coprocessor for real-time, ultra-low power computation of machine perception signals previously only computed offline on machine perception services. So with Gen 1, where you have to do all the machine perception computing in an offline workflow, now with Gen 2, this computation happens on the device in real time and can be streamed in real time to an application. And we'll show a demonstration of that. For data set creation, if you're doing offline data set creation, for example, this can save enormous effort in long duration recordings when the MP signals get included directly in what we call the VRS file. That's the container for the recordings. And if you don't need the raw camera streams, you can even omit them altogether in a profile, and the saved data can just be retained as the MP signal. That can save enormous space. And think about transferring your recording to another application. Really, when we're talking about bandwidth, that's a huge saver. But it also opens up the possibility of creating applications that can use the MP signals directly in real time. Gen 2 will also have the ability to perform automatic speech recognition on the device. So you can think about applications where you're speaking to perhaps an LLM on the other side. So when we provide Project Aria to qualified partners, we don't just provide the glasses. We provide Aria Research Kit. And that's a comprehensive set of tools for creating data sets and prototyping experiences. At a high level, ARIA Research Kit is composed of the ARIA glasses, a mobile companion app, a client SDK, machine perception capabilities that's either on device, like I mentioned for Gen 2, or via machine perception services, and tools for analyzing, processing, and packaging the data. And since we've had ARIA out there, we've observed two major workflows for ARIA Research Kit. One is data set creation. That's the creation of data sets that you can, then, for example, open source. And then also prototyping. That's, creating prototypes that have a live streaming component. So I'm going to talk about ARIA Research Kit through the lens of those two workflows. The first is data set creation. So let's start with that. We've seen a proliferation of egocentric data sets with ARIA. And even at CVPR this year, there are three primary new data sets that have been released that we'll talk about here and in Ego Village as well. University of Bristol released the HD Epic data set. Nanyang Technological University released the Ego Rice data set. And we also have Meta's own data set being released called Reading Recognition in the Wild that we did in collaboration with Ohio State University. ARIA Research Kit makes data set creation straightforward with watertight calibration across sensors and in easy ways to align multiple ARIA devices. There are profiles that can easily be configured to dial in the sensor configurations most optimal for your end research goal. And we note our core machine perception algorithms, which are location, hand, and eye tracking, which were originally developed for AM applications, available as contextual signals. Lastly, we make it really easy to load, analyze, prepare, and package your data set for model training, benchmarking, and open sourcing. And with ARIA Gen 1 now, we provide online RGB camera calibration, which enables near pixel perfect projection of masks back into the RGB camera frame, and is crucial for sensitive applications like 3D scene reconstruction. So, Richard, when you showed this example, maybe I'll just point out here, if you watch this yellow line sort of swiping across this reconstruction, you can see how with RGB online calibration, you get a very crystal clear reconstruction. And this is super critical for applications that are, immersive, and it can break immersion without this kind of detail. So this is, again, great work that our team has been doing. Okay, another close-up when we talk about, making things all work well together across different sensors and even different ARIA devices is device time alignment. And here's a closer view of what we mean by time alignment. You can see two examples on the left and the right. On the left, we see two recordings from two different ARIA devices without time alignment. And maybe it's not easy to see if you're kind of zoomed out, but once you take a look in, you can see that these recordings are not aligned. And it'd be hard to align these in post-processing manually just by eye. So we provide tools to automatically align both with ARIA Gen 1 and ARIA Gen 2. And then another thing that for those that may already be using ARIA Gen 1 is we've applied color correction in ARIA Gen 1. And you can see previous ARIA recordings may have had a bluish tint. We've now color corrected these and applied some vignetting and have tools for doing both of these. So you've seen the amazing sensor suite provided with both ARIA Gen 1 and ARIA Gen 2. And even with the battery that we've been able to pack into ARIA and our custom silicon for low power machine perception on device, power consumption and data size should be optimized for your research applications. For example, some applications can require no eye tracking camera at all, and sensors can be turned off completely to save power and recording. And that's achieved with high control over the resolution frame rate of each of the sensors using profiles. And you can use profiles via the ARIA SDK or via the ARIA mobile companion app. And with Gen 2, you'll be able to control the frequency of calculation of machine perception signals. Now I'm going to talk more about machine perception. These capabilities are available with ARIA Gen 1 via machine perception services, and they'll be available on device in real time with ARIA Gen 2. And we'll start with human-oriented signals. We have those available for eye gaze vector and hand pose, and that can provide information about what the wearer is interacting with and where their attention is. And a lot of people in the CV community have been asking about the ability to compute fully dexterous hand joint positions. We now have that available today with Aria Gen 1. You can use that today. And we'll have that available with Aria Gen 2 computed on device as well. So that's an exciting thing for those that are interested in, for example, dexterous hand robot research. We compute the trajectory of the device on the glasses in 3D space. We use visual inertial odometry. It's extremely accurate over long distances. And this is an example that shows how even the VIO and hand tracking data can be used to infer the entire human body pose. And Ming Mao will be talking more about this topic later in the conference. You can look at her oral presentation. With machine perception services, we also compute loop closure for further accuracy with the trajectory. And Richard showed this example already. This is an example of an entire block in downtown Seattle. And what's striking to me is the scale of the map that's being computed here, the semi-dense point clouds, and the detail even on the windows. So once you have your audio recordings, they're stored in what we call a VRS file on the glasses. And that's a special container for housing multimodal data. And then we have Aria Studio, which makes it easy to manage the VRS files on your glasses, transfer them to your PC, and submit them back to machine perception services for signal processing. And then once they're on your PC, you can use Project Aria tools to learn, visualize, emit, and further prepare your data set for open sourcing. And finally, if you want to do training, we have Aria Training and Evaluation Kit, which makes it very easy to process your data for use with PyTorch. So just some brief highlights, and I'm a little sensitive to time here. I know 10:15 is my limit. We have 5 minutes. University of Bristol developed HD Epic. Nanyang Technological University developed the Eagle Dash data set, which is a really interesting data set covering an entire week. Basically, people spent an entire week in a house interacting with each other, and then this data set's used for long duration QA. In the robotics space, Georgia Tech released their method Ego Mimic, which leverages scaled human data collection with Aria for robot imitation learning. And then very recently, NYU and Berkeley teamed up to release what's called Ego Zero, which is a key point-based imitation learning method that learns from human data and transfers zero shot to a robotic gripper. Okay, so just jumping quickly to talk about prototyping, this is another workflow. The main thing to talk about here is the Aria Client SDK. So this enables the Aria glasses to stream data and machine perception signals, starting with Aria Gen 2 to a client PC, where any number of experiences can be built from consuming and processing these data streams. And likewise with Gen 2, the experiences can be made interactive by enabling the user to interact with the SDK with speech and audio feedback. So imagine connecting Aria to your own fine-tuned live running vision language model, robot, whatever models you have running on your PC. And this is an example of how Gen 2 could be extended with the Aria Client SDK. We've used Gen 2 with NVIDIA's breakthrough foundation stereo model to compute depth with near metric accuracy from Gen 2's overlapping cameras. Again, we have 80 degrees of stereo overlap. And this is fused with Connect Fusion to show a mesh demonstrating the accurate depth. So I think for everybody that's been asking for a depth camera on Aria for quite a while now, this meets what you've been looking for. And another example that you may have seen when Aria Gen 2 was first announced is this example with Envision, where we have Aria Gen 2 being used interactively for spatial navigation for the blind in a grocery store. And so we're really excited to see what people can develop on their own with the SDK. And now I'm going to invite Cheng up, who's going to show us the SDK running live, and we'll just jump into a demo here. Yeah. So for a few minutes, and we'll show some features, and I'm going to swap out here. And I'm sorry for those that are on the Zoom, won't be able to see, but I'll do it with the voiceover. Okay. So we'll just get the video stream running here. Like, okay, yeah, we can see things running. Yeah. Okay, so I'll just start by describing this is a visualizer showing the SD code running in real time. And I'm going to move my hands so you just see Sean's hands. So maybe the first thing that you can notice is the RGB camera stream that's on the right. And you can see Chung's eye gaze being projected into the camera stream on the right. Mingful is rolling. Maybe if you look at her hand, you can see that the eye gaze is accurately being projected onto her hand. And then, Chung, why don't you put out your hands in front of you just to show the full 21 key point hand tracking on both hands. And then I think what's most interesting about hand tracking also, if you notice the solar CV cameras, black and white cameras, these are both outward facing and downward facing CV cameras. As he extends his hands out to the side, you can start to see the really wide range of peripheral capture that we have. And then if you also extend your hands down to a natural position in front of you, you can start to see that we have hand tracking even at a very low natural position. Maybe the last thing that we'll demonstrate is you see two audio streams in the bottom right. And so I'm just going to be talking, and you can hear my audio. You can see my audio being captured as I'm talking in the top. And then Chung's going to talk at the same time that I'm talking. Chung, can you try saying something as I'm talking? Okay, keep going, keep talking. Oh, looks like in demo fashion, we may have frozen. That's okay. Yeah. So essentially, the contact microphone enables Chung's voice to be captured even in a noisy environment when I'm talking. And so that's great for egocentric research where we're trying to capture the context of the word. Okay. Okay, so that was our research kit. Now I just want to say something that, if you want to get started right away with Aria, the easiest way to get started immediately is to download the data that we already have available to you. And we have a lot of data sets that we've created over the last few years. And these data sets span topics from human bugs estimation to realistic digital twins of environments, to synthetic environments, hand object interactions, and more. So you can download those today and get started. I'll have QR codes. So let's build the future together. This is again just all the QR codes associated with the downloads for the ARIA datasets that I mentioned, the ARIA research kit, and then reading more about, and then you can express your interest in Gen 2 when that's ready for broader release. So thanks everybody again for the time. I went maybe a few minutes over here, but I appreciate your time. And yeah, we have a few more events that will be at over the course of CVPR, and then we have our booth that'll be easy to find right near the entrance. And yeah, look forward to seeing you there and talking more.